Hello, wonderful, amazing, fantastic algebra students. This is Ms. Youngblood here with the video for our second session for the week of May 18th through May 22nd. Let's hop onto our browser and see what our topic is. So if we go to our browser, I'm in Google Classroom on the classwork section. I'm scrolling down to May 18th through 22nd, clicking on Khan Academy. And that takes me straight to my Khan Academy page. Again, if it does not take you straight to your page, make sure you are signing in with whatever email you use to sign up for my Khan Academy class. This image here shows you what assignment you should be doing. So we have 2 assignments to complete: factoring quadratics with a common factor, I believe, and factoring quadratics by grouping. So in Khan Academy, we see we have those 2 assignments that are going to be due Friday. So let's start with the first one. This is our first problem, and we're going to start by factoring out the greatest common factor and then factoring using the box method that we learned about in session 1. So I'm going to go ahead, switch to my sketch screen, and we'll be working in there. Give me a moment. As I was saying, we'll be working in our sketch screen. So I'll put our problem in here and we'll start working it out. As we learned in the previous session about factoring, the process of factoring is trying to determine what binomials were distributed in order to get this new expression. For this first problem set, we have to start by factoring out the greatest common factor. The greatest common factor is the biggest number that can go into all of these numbers evenly. Intuitively, we should see that our number cannot be bigger than 2. We can't divide 2 by any number larger than it because it will cause us to get a decimal. And if we get a decimal, then that means that it's not a factor because it doesn't go in there evenly. So the easiest way to do this is to start with the smallest number that you see. In this case, our smallest number is 2. So we're looking at our 2 and making sure that 2 goes into these numbers evenly. Negative 18 divided by 2 is negative 9. 36 divided by 2 is 18. So that means that 2 is a factor of all 3 of these numbers. So we're going to factor out the 2, and we're going to have x squared minus 9x plus 18. Again, I got these numbers with division. 18 divided by 2 is 9. 36 divided by 2 is 18. You could also check your answers by distributing the 2 back into the parentheses. 2 times x squared is 2x squared. 2 times negative 9x is negative 18x. 2 times 18 is 36. Now that we've factored out the greatest common factor, we want to factor this expression using the box method. So for our final answer, it should look something like this. The 2 in the front, and then 2 binomials multiplied together that equal this expression. We learned how to do this in the previous session. So we start by drawing our box. X squared and 18 go in the opposite squares because they don't have a common factor, and we want to make sure the diagonals are equal. So we're going to look for 2 numbers. We're going to break up this negative 9 between these 2 squares. So we're looking for 2 numbers whose product is going to be 1. Let me give myself some space. Their product is going to be 1 times 18. So that means we want their product to be 18. We want them to add to equal that negative 9. So over here, I'm going to review the products or the factors of 18. Those are the numbers that multiply to equal 18. So we have 1 and 18. We have 2 and 9. 3 and 6. And that's it. 18 divided by 4 is a decimal, and 18 divided by 5 is a decimal. So we have ensured that we have all the factors of 18 to consider. If we look at these values, we know that both of the values have to have the same sign to equal positive 18 when they are multiplied, and they have to both be negative in order to equal negative 9 when they are added. So that's going to get us negative 6 and negative 3. So these are the 2 factors that we used. So in these boxes, we're going to have negative 6x and negative 3x We can factor out an x from this first row because both of these terms have an x. We can't factor out any numbers because of this 1. So that means we need an x up here. X times x is x squared. X times negative 6 is negative 6x. In this box here, negative 3 times x is negative 3x. And just to verify that our numbers are correct, we can check that negative 3 times negative 6 is 18, which it is. So our two factors are going to be x minus 3 and x minus 6. So this would be the answer we would type in to Khan Academy. So when you type that answer in, you want to make sure that you have the 2 in front. Otherwise, the system will mark you incorrect. Cool. So there's just one more problem I have in my set because I already did the first 2. So we'll put this in our sketch pad and go from there. This is our next problem in the set, 6x squared minus 18x minus 60. So again, we want to see if our smallest number, which is 6, goes into 18 and negative 60 evenly, which it does. So we're going to have 6 times x squared. Negative 18 divided by 6 is negative 3x. Negative 60 divided by 6 is negative 20. So we factored out our greatest common factor, and now we want to see how is this going to break down further by using our box method. So we're going to draw our box off to the side. In the upper left corner, we're going to put the x squared. Remember, there's an imaginary 1 in front. In the bottom right corner, we're going to put the negative 20. In the other 2 boxes, we're breaking up the negative 30. I believe I did something incorrect. I did. When I factored out 6, 60 divided by 6 is 10. No idea how I got 20. So that should be a 10. And this should be a 10 as well. Okay. So we are going to try to break up this negative 3x between these 2 boxes, but we have to make sure that when they're multiplied together, they equal these 2 numbers as well. So we're looking for 2 numbers whose product is 1 times negative 10, which is negative 10. So 2 numbers that are going to multiply to equal negative 10, but add to equal negative 3. So let's think of our factors of negative 10. For negative 10, we have 1 and 10, 2 and 5, and we can stop there because 10 divided by 3 and 10 divided by 4 are decimals, therefore 3 and 4 are not factors of 10. So we have to figure out which of these 2 pairs we can combine to get negative 3. This is the option. So we have 2 and 5. In order to combine 2 and 5 to get negative 3, the 5 has to be negative. So 2 times negative 5 is negative 3. 2 plus negative 5 is negative 3. 2 times negative 5 is negative 10. So those are the 2 values we're using in our square, 2x and negative 5x. So now let's figure out the rest of our square. If we look at this row, we can factor out an x and a 1. You don't have to put the 1 if you don't want to. X times x is x squared. X times negative 5 is negative 5x. X times 2 is 2x. And we can check the last ones. 2 times negative 5 is negative 10. So our factors are 6, x minus 5, and x plus 2. So this is going to be our final answer for this problem. If you are already getting the hang of the process of factoring these expressions by factoring out the greatest common factor first, you can skip this portion of the video, but I do want to do 2 more examples for those who might still need some more examples to understand it. So in our next example from my Khan Academy set, I just restarted it. The greatest common factor we can factor out between 3, 33, and 90 is this small number 3. So if we factor out 3, we're left with x squared. 33 divided by 3 is 11, so we have plus 11x. 90 divided by 3 is 30, so we have plus 30. So again, we've only factored out the greatest common factor, 3. So now we just need to figure out what was multiplied to get that x squared plus 11x plus 30. Let's draw our box. Make sure we leave ourselves some room to look at the factors and do our next problem. In the upper left square, we're going to have this 1x squared. In the bottom right, we're going to have this 30. So now, in the remaining two squares, we need to break up this 11x. So we are trying to find two numbers that are going to multiply to 1 times 30, which is 30, but they still need to add to that 11. So we need two numbers to multiply to 30 and add to 11. We have to consider all the factors of 30. So we have 1 times 30 is 30, 2 times 15, 30 divided by 3 is 10, 30 divided by 4 is a decimal, so we'll skip that value. 30 divided by 5 is 6. So now we have all of our factors, 1, 2, 3, 5, and then the numbers increase on that side. So the two values we can combine to get 11 are 5 and 6. So we would have 5 plus 6. So that means we're going to break up this 11x into 5x plus 6x. Again, that ensures that the 11 is here, 5 plus 11, 5 plus 6, and that the diagonals are equal, 30 and 30. So in this first row, we can factor out an x. If x goes here, x times x is x squared. X times 6 is 6x. X times 5 is 5x. 5 times 6 is 30. So again, we're just working backwards. So our final answer for this one is going to be x plus 5 times x plus 6. And you still have to make sure that that 3 remains in the front. This will be our last problem that we'll be going through from this set. So we're given this expression, negative 3x squared plus 6x plus 9. The smallest number we have is negative 3. So let's see if negative 3 is a factor. Negative 3 divided by negative 3 is 1x squared. 6 divided by negative 3 is negative 2x. 9 divided by negative 3 is negative 3. So we have factored out our greatest common factor, and now we are trying to factor the remaining expression further. What was multiplied to get x squared minus 2x minus 3? I'm going to construct our box. In the upper left corner, we have x squared. Bottom right is negative 3. Then we need to split this negative 2 between these two boxes. In order to do that, we need to ensure our diagonals are equal. So we need to find two numbers that multiply to equal negative 3, but add to equal negative 2. If we think of our factors for negative 3, we just have one option, 1 and 3. So we have to use 1 and 3 in some way to get negative 2. In order to get negative 2, the 3 would have to be negative. 1 plus negative 3 is 2. So that means we're splitting this negative 2x into 1x and negative 3x. So for our final answer, in this first row, we can only factor out an x. Now we can work from here. X times x is x squared. X times negative 3 is negative 3x. X times 1 is 1x. And 1 times negative 3 is negative 3. So our answer is going to be negative 3 times x plus 1 times x minus 3. So let's type that in for this last problem. So we said we had negative 3 times x minus 1 times x plus 2. Honestly, don't remember. Okay, so we are looking at our final answer, x plus 1 times x minus 3. My apologies, I just had a few notifications from my students. X plus 1 times x minus 3. Okay. Check. Minus 3 is what I get. Okay, so that's where we'll end on that problem set. And then for this one, we'll have time to do all 4. Yes. So in this one, we have 4 problems. For this problem set, the focus is not on greatest common factor. It's just focused on factoring when the number in front is not equal to 1. But it can be a little challenging, but if we use the same process, it makes it a little bit easier to manage. So again, I'll copy this over and put this in my sketchpad. Again, we are given this expression. We're not factoring out the greatest common factor. We're just looking right away at what 2 binomials will multiply to get this expression. So we're going to jump straight to our boxes. And we're going to have 3x squared and negative 7. So again, I just started by putting these 2 terms in their respective boxes. Now we're going to break apart this negative 20 between the other 2 boxes. Again, the diagonals have to be equal. So we need to make sure that whatever numbers we put in there, they have the same product as 3 times negative 7, which is negative 21. So we're looking for 2 numbers that are going to multiply to equal negative 21, but add to equal that negative 20. If we quickly review our factors of 21, we have 1 and 21. 21 divided by 2 is a decimal, so we skip 2. We have 3 and 7. 21 divided by 4, 21 divided by 5, and 21 divided by 6 are all decimals, so those are not factors. So these are our only options for the factors. The 2 numbers we can combine to get negative 21 will be 1 and 21. So we're going to have 1 and 21. In order for them to add to get negative 20, the 21 must be negative. So those are the numbers that are going to go in our boxes, 1x and negative 21x. So again, the diagonals are equal. 3 times negative 7 is negative 21. 1 times negative 21 is negative 21. So now there's a little bit more thought involved when finding our first value. We know that both terms have an x, so we can factor out the x. But now we have 2 numbers to work with, not just the 1. So between 3 and 21, the smallest number that can be factored out is 3. So this first box is going to be 3x. Again, that's because of this 3 right here. So because of this 3 and this negative 21. 3 is a factor, the greatest common factor of 3 and 21. So now we can figure out the rest of the spaces because we've already planted this first factor. So if this is 3x, 3x times x is x squared. 3x times negative 7 is negative 21x. X times 1 is 1x. And to check our last one, we can do 1 times negative 7 does equal negative 7. So our factors for this expression are going to be 3x plus 1 and x minus 7. For our next problem in the set, we are given this expression, negative 7x squared minus 24x minus 9. When solving or simplifying this expression, we just have to be very careful and make sure that we are being consistent with our signs. So we're going to start by drawing our box. In the upper left, we're going to have negative 7x squared. Bottom right will be negative 9. So now we're going to split this negative 24x between the other two boxes while making sure the diagonals are equal. So we're looking for two numbers with the same product as negative 9 and negative 7, which will be 63. So we want two numbers whose product is positive 63 and that add to negative 24. So let's think about our factors of 63. 1 and 63. 2 does not go into 63, so we will skip it. 3 and 21. 4 does not go into 63. 5 does not go into 63. 6 does not go into 63. 7 and 9 and 8 does not go into 63. So these are our three factor pairs for 63. We can see that 3 and 21 look like they have the most promise. So if we put 21 and 3, they both have to be negative in order to add to negative 24 and multiply to positive 63. So in the box, we're going to have negative 21x and negative 3x. Again, negative 21 plus negative 3 gets us this negative 24x. Negative 21 times negative 3 gets us 63, which is also negative 9 times negative 7. So we've chosen the right values. Now, we need to factor out the greatest common factor here. So between negative 7 and negative 3, there actually is no greatest common factor. So we can just factor out x. They both have an x, but we can't divide 7 and 3 by the same number and still get a whole number. If this is x, this up here has to be negative 7x, because negative 7x times x is negative 7x squared. This has to be negative 3, because negative 3 times x is negative 3x. And this has to be positive 3, because 3 times negative 7x is negative 21x, and 3 times negative 3 is negative 9. So our factors are going to be x plus 3 times negative 7x minus 3. For our next problem in the set, we have negative 3x squared plus 17x minus 20. So again, we're just going to jump straight to the boxes. I'm going to draw that better. Okay. In the upper left box, we're going to have negative 3x squared. Bottom right, negative 20. Again, we're looking for two numbers that will multiply. Oh, I'm sorry, we're trying to figure out what two binomials will get us negative 3x squared plus 17x minus 20 when they are multiplied together. We need to split this negative 17x between these two boxes while ensuring the diagonals are still equal. So we're looking for two numbers whose product is going to be 60, and that add to that 17. So let's think of the factor pairs for 60. 1 times 60. 60 divided by 2 is 30. 60 divided by 3 is 20. 60 divided by 4 is 15. 60 divided by 5 is 12. 60 divided by 6 is 10. 60 divided by 7, 60 divided by 8, and 60 divided by 9 are all decimals. So we will skip those numbers, and these are all of the factor pairs for 60. So there are actually two options that look promising to me when I'm looking at these numbers. I see 3 and 20, and I see 5 and 12. So if I do 20 minus 3, I can get 17. If I do 5 plus 12, I can get 17. So we have options. However, we have to make sure that it multiplies to positive 60. In order for it to multiply to positive 60 and add to a positive number, both of our numbers have to be positive. So we can't use this option because the only way it would work is if the 3 is negative, and we can't have any negatives. So it has to be 5 and 12. Again, that's just something that comes with practice and patience to be able to see that this is going to be the best option. If you didn't know off the top of your head, you could have tried this, tried negative 3 and 20, but you also have to verify that it multiplies to positive 60, which it does not. Regardless, our final answer for these two boxes, not our final answer, but our answer for these two boxes is going to be 5x and 12x. So now we're looking at these two boxes. The greatest common factor we can factor out would be 3. You can factor out 3 or negative 3. I'm going to try to get out this negative as soon as possible. I'm going to adjust for a moment, then I will be right back. Okay, so as I was saying, we're going to factor out this negative 3, so we would have negative 3x here, because 3 goes into 3 and 12, and both of these terms have x's. This is negative 3x times x would get us x squared. Negative 3x times negative 4 would get us positive 12x. X times 5 will get us x, and 5 times negative 4 will get us negative 20. So our factors are going to be negative 3x plus 5 and x minus 4. So that's our final answer for this problem. For our last problem in the set, we are given this problem. 6x squared minus okay 6x squared minus 13x plus 6. So again, we're looking for what two binomials are multiplied to get us that expression. Let's draw our box like we've been doing for the 7 problems that came before this, and like we did in the 7 problems before. The 6x squared is going to go in the upper left corner. The 6 is going to go in the bottom right corner. And now we have to split this negative 13x between these two boxes. But we have to ensure that the diagonals multiply to get the same number. So we're going to have to make sure that we are finding two values that multiply to get us 36, but add to get us negative 13. Off the top of my head, these values don't come to me. So I'm still actively searching for these factors in my head, and this is the process that I'm going through. If I look at 36, I have 1 and 36. Can't combine those. 2 and 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 divided by 5 does not work because it's a decimal. 36 divided by 6 is 6. So we have ensured that we have all of our factor pairs. Looking at these, 4 and 9 look like the only option we have to combine to get 13. So we have 4 and we have 9. Positive 4 times positive 9 does equal 36. However, it does not multiply, it does not add to equal negative 13. In order for that to happen, you have to make both of them negative. So negative 4 times negative 9 is 36, and negative 4 plus negative 9 is negative 13. So these are the two values we're going to put in our other squares, negative 4x and negative 9x. Again, negative 13x is here, negative 14x minus 9x. And we have also made sure that our diagonals are the same. 6 times 6 is 36. Negative 9 times negative 4 is positive 36. Now let's look at this top row. The greatest common factor between 6 and 9 is going to be 3. We can also factor out an x because both terms have an x. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. 2x times negative 2 is negative 4x. And negative 2 times negative 3 is 6. So our factors are 3x minus 2, 2x minus 3. We switch back to our browser. 3x minus 2 and 2x minus 3. It's always so hard for me to remember what I wrote. 3x minus 2, 2x minus 3. Okay. So that should be our final answer. Yay! All done. Okay. So those are your 2 problem sets for session 2 for algebra this week. Again, these will be posted here, or you can look on YouTube if you want to find them a little bit faster. If you have not already, make sure you take the time to complete the weekly check-in for this week, and make sure you are going to your classes and checking in with your teachers by following the schedule that I have posted right here. If you have questions, please do not hesitate to reach out. You can text, email me if these videos are not enough. Again, you can ask me your specific questions, and I have no problems with helping you because that is my job, and I love you and I miss you. Thank you so much for taking the time to watch this video. And again, if you need anything, email me or text me. I hope to hear from you or see you soon. Bye.